Good day, boys. Good day, girls. How are you? Hope you are fine. Hope you are safe. This afternoon, we're carrying on with our math lesson. So today, we're going to start afresh from a new topic. Today, we'll be looking at statistics. We're looking at data ending statistics in a proper term. So today, we'll be looking at the basic recap of what you have done in the previous grades, and then that will serve as foundation for us to build on for this grade. Okay, before I carry on, my name again is Sado Jafaru Abdullahi, and our today's topic is statistics. Okay, so today's lesson will be centered on basic recap of what have been taught in the previous grades. Okay, so at the end of today's lesson, we should understand the importance of statistics, the important statistic terms studied in the previous grades, such as the mean, the concept of the mean, the median, the mode, the range. When you talk about the mean, you talk about the mean of group and ungrouped data, median of group and ungrouped data, and the mode, and then the range, the interquartile range, and then talk about the different quartile, the upper quartile, the middle quartile, which is the median, and the lower quartile, and talk about the interquartile range. Okay, and then we talk about the box and whisker diagram. At the end of this lesson, you should understand box and whisker diagram, the cumulative frequency, and then with that the Auger graph, and then the histogram. So in the box and whisker diagram, you should understand the skewedness, the symmetry of the data, how they are spread around the mean. Okay, at the end of this lesson, you have a good grip of those. Okay, right. So, as I said, today is a recap of what I've learned in our previous lesson. So, you're saying, although box and whisker plot is useful to show the spread of data, we cannot always be sure whether the data is symmetrical or skewed. So, what is symmetrical data and what is skewed data? So, that you're going to understand as the lesson progresses. Right. So, we must determine the mean. We must determine the mean of the data to make sure. So, we need to find the median and to know if a data is symmetrical or not. So, what we need to do is to check the position of the mean, the median, and the range. And then from there, we can know if the data is symmetrical or is skewed. When do we say data is symmetrical? When the value of the mean, the mode, and the median are equal. So data are symmetrical when the mean value, median, and the mode value are equal. So we say they are symmetrical. But when this is not, then we say they are what? Skewed. So depending on what the mean and the median is, to determine which direction is the skewedness. Is it skewed to the right or is it skewed to the left? Is it positive skewed or it is negatively skewed? What you're saying is the major thing is to compare what is important. What is important is to see how the mean compare with the median. So look at the mean and the median. So when we have a perfect symmetry, then the mean, that the median value, the mode, the frequency, the mean will be the same, as shown in the figure in the frequency polygon below. In saying for a symmetric data, the mean, the median, and the mode will be equal, will have an equal value. So data represented like this is a bit symmetrical. It's a bit symmetrical. So when mean calculated, the median and the mode are the same value, then this was symmetrical, meaning there is no spread on either side. Okay, so this is symmetrical data. Symmetrical data is represented as this. So when is the data skewed? Okay, so let's see next. Right. So now consider the histogram below. Look at a data that is given like this. This is an histogram that presents a particular data. So what can be said about this kind of data in terms of skewedness or being symmetrical? So now, all we need to do to determine if a data is symmetrical or skewed is to check the mean value and the median position. So now with this histogram, here now you can see here, this is the median position. Here the median position is the green one, but the mean position is on the right. That means the mean value is higher than the median. So when the mean value is greater than median, when the mean value is not exactly the same as the median, then we say the data is not symmetrical, then it's skewed. Because the mean and the median, we say for it to be symmetrical, the mean, median, and the mode have to be the same value. But in this case, the mean and the median are not the same. So the mean and the median, the mean and the median are not the same. Here the mean is bigger than the median. So in this case, we say the data is skewed. Is what is skewed? It is what not symmetrical. Okay, it's not symmetrical, it's skewed. And how it is skewed? So it is skewed to the right. Within this data represented with this kind of histogram is skewed to the right. So because the mean is higher than the median. Okay, so when we have the data whereby the mean is greater than the median, then we say it's not positively skewed, or it is skewed to the, or it's skewed to the right. Okay, and then giving a data represented with this histogram, for example, an age of maybe some group of students, so represented with this histogram, so you want to know the skewedness of the data. You want to see the skewedness or the symmetrical. So 52 represents the median, 52 representing the median, and then the mean calculated is 51. So 51 is the mean, 52 is the median. So that means the mean is now less than the median. The mean is less than the median. So we're saying this data is not symmetrical, but it is negatively skewed. The data is negatively skewed, it is skewed to the left. That is skewedness. And then symmetrical. A data can be. So you should be able to understand this concept. Okay, so and then using both we can represent a symmetrical data as this. So data represented like this is set to be symmetrical, whereby the median is in between the upper and the lower quartile. Remember in your Boston and Whisker diagram, to get to Boston and Whisker diagram, you need your 5 number summaries. Remember, you need your 5 number summaries. What are the 5 number summaries? Is the maximum value, the upper quartile, the middle quartile is also referred to as the median, and the lower quartile, and lastly the minimum. The minimum. Now the maximum, the minimum, the upper quartile, the middle quartile or the median, and the lower quartile. These are your 5 number summary to sketch your Boston and Whisker diagram. Again, in the Boston and Whisker diagram, we have the maximum, the upper quartile, the middle quartile, the lower quartile, and the minimum. Okay, so now we're saying if the middle quartile or the median is in between, is just equal, just balance between the middle quartile and the upper quartile and the lower quartile, then we say it's symmetrical. With symmetrical data is represented like this on the Boston and Whisker. So the Boston and Whisker can be used to show the skewedness, the spreadness of the data, how are the data distributed around the mean. Okay, so this is symmetrical data. Data represented like this of this data is symmetrical. So, and then when data is represented like this, when the Boston and Whisker that is drawn for a particular data is given like this, then we say it is skewed to the right. It is partially skewed. So basically, I say it is what spreadness. The skewedness represents spreadness. Spread to the right. That means many of those values are towards the right. Okay. And then when a data is represented like this, then we say is what the median, this is negatively skewed, and the space on the left is more than the space on the right. So we say what negatively skewed, it is skewed to the left. Okay. So this is how we summarize data and data. Skewedness of data. Okay. Now we can conclude now that if the mean is equal to the median, then the data is symmetrical. For symmetrical data, the mean equals to the median. But when the mean is greater than the median, then the data is skewed to the right. And if the mean is less than the median, then the data is skewed to the left. Right. Because in some of your exams, they will tell you comment on the skewedness of the data. They will ask you, comment, you'll be given a question, and then the question will be comment on the keywordness of the data. So with your value of your median, you can decide, you can determine, you can say how skewed the data is. Okay, right. Let's see an example. Now, what example? Now we see now that the frequency table shows the results achieved by Shivan's class in mathematics test push out of 45. The test out of 45. So this is their result. This is the marks of learners in a test that is out of 45. Determine any relevant information to discuss the distribution of the symmetry of the given data. Okay, now this is the marks distribution. This is how much marks. This is the representation of the marks scored by learners in a MET test. Okay, so now the question is determine relevant information to discuss the distribution of, and the symmetry of the given data. So how is the data distributed and what is the symmetry of the data? Right. So the first thing to do when you think about keywordness, we talk about the mean, find your central tendencies, find all your major central tendencies, which is your mean, the median, as well as the range. Then find your quartiles. Again, first find your mean, find your median, find your mode, find your range. Okay. Now find your lower quartile, the upper quartile, and the interquartile range. And then from there, you can now be able to sketch your Bose and Whisker diagram. And from there, you can determine the keywordness of the data. Okay. So to explain or to give the basic information you can get from this data is the mean. Let's think about the mean. How do you find the mean in this case? How do you get the mean of this mark? What is the mean mark? Yeah. How do you find the mean mark? What is the mean mark of the learners in this MET test? So what does this tell us in part? This tells us that what? That 12 learners get between mark of 20 and 30. 12 learners get marks between 20 and 30. And then 20 learners get between 30 and 40. 40 learners get between 40 learners get marks between 40 and 50. 7 learners get between 6 and 70, and 10 learners get between 60 and 70, and like this. I mean, in that order. So this is the number of learners, and these are marks. The limit to their marks. Okay. Now, the question now, first question is how to find the mean mark. How to find the mean of their mark. So the first thing to do to find the mean, what do? You first have to find the midpoint. You have to find the midpoint. How do you get the midpoint? You add the maximum, the upper limit, plus the lower limit divided by 2. Again, the question is we are starting off with the mean mark. Trying to determine the mean mark. You need to get the mean, you need to find the midpoint first. To get the midpoint, we say the upper limit plus the lower limit divided by 2. So that will do for all of this. That okay, we call it the upper limit, now the lower limit, so we are calculating the midpoint. We say 30 plus 20 divided by 2. That plus 20 will be 50. Okay, 50 divided by 2 will be 25. That means the mid mark is 25. So the same thing, 40 plus 30, 70, 70 by 2, that will be 35. So our mid mark, the midpoint, the mid mark is what? 35 here. Here will be 45. How? 90 plus 40, 90, 90 by 2 is 45. Then there will be 55. 60 plus 50 is 110. 90 by 2, 55. Then there will be 65. Then we have 75, we have 85, and we have 95. 95 how? With the 100 plus 90, that will be 190. So 190 divided by 2, that gives us 25. So this will be your mid-mark. First, calculate your mid-mark. So with your mid-mark, you have to multiply your mid-mark with your frequency. The number of learners be taken as your frequency. The number of learners be taken as your frequency F. So your mid-mark be taken as what F. So the mid-mark being X, the number of learners being F. So from there, you find your Fx by multiplying your F and your X. Okay, the 25 here multiplied by 12. 25 multiplied by 12, 35 multiplied by 20, 45 multiplied by 14, 55 multiplied by 7, 65 multiplied by 10, 75 multiplied by 16, 85 multiplied by 20, 90 multiplied by 12. So we add all our fx and then divide it by the total number of this. So we need to find our total number. So we just define our mean. We divide our fx by f. Find your fx, add them all together, and then divide by your f. How do you get f? You add all this together. Again, mean by formula is equal to sum of fx over sum of f. Sum of fx over sum of f. How do you get x? X is your mid mark. That you get by adding the average of these two marks. Add these two numbers of limit plus 1 by 2 get your mid mark. So this is your frequency. So your x with your mid mark multiplied your frequency will give you fx. So have fx, then you're going to find sum of all your fx. You add all your fx together and then add all your f's together and divide the value, divide the two answers and get your mean. Okay, so let's get our mean. Okay, now how do you find the median? How do you find the median? To get the median of this, what do we do? To find the median, we use our median formula. Our median formula says what? 1 plus n divided by 2. Remember, our median is what? 1 plus n divided by 2. So we need to find our n first. Our n means our total number. Our total number. Adding up all this together, our sum of f. So we're going to say 12 plus 20 plus 14 plus 7 plus 10 plus 15 plus 20 plus 12. That would be 101, 111. We add all this together, I get 111. So 111 plus 1 divided by 2 to find our median. 111 divided by 2. And then we try to find the position of that. So let's see what we say in them. Let's see as we go ahead. So for determine the mean. How do you determine the mean? So to find the mean, you can say 25 multiplied by 12 plus 35 multiplied by 20 plus 45 multiplied by 14, 55 multiplied by 7, 65 by 10, 45 multiplied by 15, 85 multiplied by 20, 95 multiplied by 12, divided by the total number of your frequency. The number of frequency is 111. So you're going to, once you divide this, then you're going to have what? 60.41. So your mean is 60.41. Okay, so that's the main value. Right, that's what I mean. Now, next, another important term we can find is the median. So how do you find your median? You use your formula. So you continue that out. You find your median. Okay. So your median is n plus 1 divided by 2 with a position. So the total number is what? 111. 111 plus 1 give you 112. 112 by 2 give you 56. So if you estimate the median score, we will know that the middle value is 56 value. The middle value is the 56 value. How do we it's around 50 and 60. Our mid class here is around 50 and 60. Okay, so now what do we do here? What do we do? So basically what do we do here to find our median? So the same, if you estimate the median score, we would know that the middle value is 56. So we add all our values up to the 56th position. So if you add this 12 plus 20, 32, 32 plus 14 will give you what is this? 46 plus 7 will give you 53. 53. So the middle position will be in between what, 60 and 70. Okay, the middle position will be in between 50, 60 and 70. Okay, so our mid class will be 60 and 70. Now, how do you find the exact mid position? How do you find the exact mid position? To find the exact mid position, then we use the ogive. You need to draw the ogive. So drawing the ogive, then you have your vertical axis and your horizontal axis. So then you put your values based on what you have on your vertical axis, based on your marks, you put values on your vertical axis, and then you put your class intervals on your horizontal axis. You put class interval on horizontal axis, and then your frequency, your cumulative frequency on the vertical axis. Okay, so our frequency, our cumulative frequency on our vertical axis, we can get our cumulative frequency. How do you find our cumulative frequency? When I say 12 plus 20, whatever you get, plus 40, plus 14, plus 7, plus 10, plus 16, plus 20, plus 12, that will give us our cumulative frequency. Okay, so the cumulative frequency will be plotted on the vertical axis, and then the class interval mark will be on the horizontal axis when plotting our ogive. Okay, so you have 10, 20, 30, 40, 50, up to 100, yeah? And then your intervals are between what? What are our intervals again? Our interval is from 20 to 30, 30 to 40. So here you have here 20 to 30. So we have 20 here, 40, 60, 80, and 100. Okay, now, and then we plot our ogive, and then we have the curve that goes this way. Okay, right. So now, from here, we can determine our median. How to find our median? We can find our exact value of our median. How? By calculating our middle position. How to find our middle position? Our middle position can be calculated by saying what? 101, 111 plus 1, which is 112. 112 by 2 is 56. So you're going to look for 56, go by here on your vertical axis, go to your 56 and trace it until you get to your ogive and see where, what marks that corresponds to. You read up your 56 from the horizontal on the vertical axis, go by, look for 56 on vertical axis, and then go there and then look wherever it touches the ogive, check it down and see what mark that corresponds to. So, and then if you do that, our middle mark will get 61. Our Q2 will be around 61. Okay. And then to find our Q1, the lower quartile, what do you do? How do you find lower quartile? You say 1 plus n over 4 with TH. So you're going to say 111 plus 1 divided by 4. So, and then whatever that gives you, then look for the position. So our Q1 will be 37. So our Q1 will be 37. Our Q1 will be 37. And then to find our Q3. How do you find our Q3? Again, we say N. What's N? N means what? Our total frequency. All our frequencies add together, which is our total cumulative frequency, which in this case is 111. 111 plus 1, that will be 112. 112 divided by 4, then multiply by 3. So when we get that, with that, we look for what that corresponds to. And then if we check on that, you're going to have a value of 80. So our Q1 is 40, our Q2 is 61, our Q1 is 37, our Q2 will be 61, and our Q3 will be 82. Okay, right. So from here, from our Q1 and Q3, we can find our interquartile range, IQR. We can find our interquartile range. Interquartile range, IQR, is giving us Q3, the upper quartile, minus the lower quartile. The upper quartile being what? Upper quartile being 83, lower quartile being 37. So 83 minus 37 will give us our interquartile range. Our interquartile range will be 45. Okay, so those are our values. So with this ogive, we can as well create our box and whisker diagram. So remember, in a box and whisker diagram, there was the maximum value. So with this, we can find our maximum value. Our maximum value there is our maximum value on the table. We can get the maximum value was 100. The maximum value is a value around 100, something very close to 100, but not exactly 100. So that will be our maximum value will be somewhere here. Our Q3, our Q2, Q1, and the minimum here. So with this, with the ogive, we can create our box and whisker. So if when after creating our box and whisker, so looking at the box and we can see here that it is this data, the whole data is fairly what? Fairly symmetry. Because if you look at our main value, our value of our main 60.41, and the value of our median, which is our Q2, which is 61. So 60.41 and 61 are very close values. They are very close values. So we can assume, we can say confidently that this data is symmetrical. So this is a symmetrical data, meaning and then if you check the mode now, we check the mode. Let's see the mode on the table. Let's see how the mode compare. What is the modal value here? What is the mode? The mode is that one with the highest frequency. And we say frequency means our number of learners. Our frequency is our number of learners. So the mode is the class with the highest frequency. So our modal class will be 30 to 40, which corresponds to 20, as well as 80 to 90, also 20. So this is bimodal. We say the data is bimodal. So our mean class is what? 60 to 70 is our main class. And then our median class also around 60, a median class 60 to 70. So the mode is fairly distributed around the median. So that tells us that it is what? It is symmetrical. It's a symmetrical data because you check the mode here. These are two modes. There are 20 as a mode, there are 20 as a mode. And then we say our median class is 60 to 70. So the mode are fairly distributed on both sides of the median. We say the data is symmetrical. Okay, so let's see another example then. Example 2. The box and whisker plot below represents the distance run by athletes from two different running clubs over a period of 1 month. Okay, so the box and whisker for club A is given as this, and the box and whisker for club B is given as that. Okay, right. What features are the same for both clubs? What features are same for both clubs? So for both clubs, if you check nicely, the same for both and whisker. This here is your minimum value. There is the lower quartile, the middle quartile, the upper quartile, and the maximum. You can see the maximum are the same. They have the same maximum values. Okay, the maximum values here are the same amount, and then as well as the median value are also the same. So the median for both clubs are the same as well as the maximum value. Okay, it seems that there is no significant difference in the performance between the two clubs. Is this conclusion valid? The upper limit here is 98, okay? And then the lower limit, the maximum amount is 98, and the minimum here is 32. And then the lower quartile for club A is 68, the middle quartile is 80, and then the upper quartile is 90. Compared to the club B has an maximum of 98 as well, but a minimum of what? 68. The minimum is 68, the maximum is 98. But here the minimum here is 32, the maximum is 98. So the lower quartile here is 74, but the lower quartile here is 68. Yes, the middle quartile are the same, but the maximum here is 94, the maximum is 90. So by comparing all these 5 number summary, we can conclude that Club B did much better than Club A. Okay, comment on the distribution of the data for Club A if the mean is 76. So if the mean is 76, so what is the distribution of the data for Club A? So if the mean is 76, that means what? The data for Club A is negatively skewed. Because if that is compared with the median, if you compare the mean with the mean being 78, the median being what, 80. We say if the mean is less than the median, then we say the data is negatively skewed. So the data is negatively skewed. That means it is skewed to the left. So again, comment on the distribution of this the distance for Club A if the mean is 76. So if the mean is 76 and the median is 80, so 76 is less than 80, that means it's negatively skewed. Okay, we say the data is negatively skewed, right? Then, or it is skewed to the left. Then, question B says determine whether the minimum or the maximum value for Club A are determine whether the minimum or maximum value for Club A are outliers. So we can say that what the minimum value for Club A is outlier, but Club for the maximum value is not outlier. So you only have one outlier, which is the minimum value. What is an outlier? An outlier is that amount, is that number or that data that is too far or too big or too small compared to the rest of the data. So compared to the rest of the data, we're saying that what? An outlier is that number or data that is too small or too big compared to the rest. So if you look at the Boston Analytica for Club A, you see that the minimum value is an outlier, it's an amount that is too small compared to the rest of the data. Okay, because if you look at the lower quarter here is 78 and the middle quarter is 80. Okay, so 32 will be seen as an outlier compared to the rest of the data. Okay, next question. Does Club B have any outlier explain? Does Club B have any outlier? So looking at the Boston for Club B, there is no outlier for Club B. So there is no particular value here that's too big or too small compared to the rest of them. So there's no outlier for Club B. Okay, I hope you understand what I'm explaining. So looking at example 3, the following histogram represents the distance run by few comrades marathon runner who didn't complete the 98-kilometer race. So these are histograms to represent the race. So these are the frequency, this is the distance they ran. These are in kilometers. Okay. So what does this imply at first? This implies that zero people, one person ran what? 10 kilometers. That 10 kilometers was run by one person. And that those who run between 10 kilometers to 20 kilometers, they are 6 in number. And those who run between 20 kilometers to 30 kilometers are 12 in number. Those who run between 30 kilometers to 40 kilometers are 16 in numbers. And then it carries on like that. So those who run between 40 to 50 kilometers, they are 10 in number. Those between 50 and 60 are 4 in number, and 60 to 70 are 2 in number. Okay, so these are their frequencies. Okay, that is the implication of the histogram. Now the question is redraw and complete the following table. So we need to redraw and complete this table. So now, how do you fill in this? What are the frequencies? So we already said 0 to 10 had a frequency of 1. So between 0 and 10, the frequency is 1. Between 10 and 20, the frequency is 6. Between 20 to 30, the frequency is 12. 30 to 40, frequency is 16. 40 to 50, frequency is 10. 50 to 60, frequency is 4. And then 60 to 70, frequency is 2. Okay, so with that, complete our frequency table. So once the frequency table is completed, then we calculate our cumulative frequency. How to find our cumulative frequency is by adding up our frequencies here. So the first frequency will be placed on this first block, and then the first frequency being 1, so we're going to have here 1. So we're going to have 1 then, and then the next is going to be 1, 6, 12. So we're going to have here 1, 6, 12. So the first one being 1, the next one being 6, the other one being 12. We are going to have 1 plus 6, we have 7. 7 plus 12, we have 19. So we keep adding our frequencies to calculate our cumulative frequency. So as we add this column with this column, so we get our cumulative frequency. So with that, we calculate our cumulative frequency. Okay. Now the next we do point by point plotting of the values. Okay. And then with that, we get our OGIV, our OGIV curve, our frequency cumulative frequency curve. And then to determine or estimate the quartiles, so we calculate our lower quartiles, the middle quartiles, and then to find our lower quartile, we say our total number. We get our total number by adding all our frequencies. So to find our lower quartile Q1, so Q1 will be total number plus 1 divided by 4, and then we calculate that, and then calculate our lower quarter and as well as our upper quarter, and then with that we can estimate that on our OGIV. So we can see where, check the value we have, we check it on the curve, and then we can find what the value of the quartiles, what they correspond to. And then to find the 60th percentile, the same percentile you calculate by saying 60 over 100 multiplied by your total frequency. And then the G question, draw a box and whisker diagram if the minimum distance is 10 kilometers and maximum distance is 70 kilometers. So we draw our minimum. We said to draw our box and whisker with 5 number summary, the maximum, the minimum, the lower quarter, middle quarter, and the upper quarter. So with those 5 number summary, we get our box and whisker diagram. And lastly, comment on the distribution of the data in terms of the keywordness. Their skewness will be determined using the mean and the median. So when the mean is less than the median, then we say it's negatively skewed or it's skewed to the left. And then when the mean is bigger than the median, then we say it's positively skewed. So we end the class here today, and then we continue from there in next lesson tomorrow. Okay, enjoy your day and be safe. Okay.